day, students. So for today, we are going to have a lesson which is pattern and algebra and factors of polynomial. But first, let us define what is pattern and algebra.
Algebra is a branch of mathematics that deals with the general statement of relations, utilizing letters and other symbols to represent a specific set of numbers and values and their relationship to one another. While patterns are important in the early stage of the development of algebraic thinking, also, pattern and algebra strengths support thinking, reasoning, and working mathematically. The students have to extend their thinking beyond what they see to generalize about situations involving the unknown. Algebra, language of generalization, describe patterns using words and graphs, developing symbols that express generalizations, language of relationship between quantities, language used to solve problems. We use patterns as a stimulus through investigation to lead to understanding the algebraic concept. Here, we get the numbers in the pattern by skip counting by 5. In this pattern, we see that every term in the sequence has grown or increased by 6, or the difference between the two consecutive numbers is 6. So we can get the next term by adding 6 to the previous term. In this number pattern, we can see that every term in the sequence has been reduced by 3, or 3 has been subtracted from every number compared to the previous one. So we can subtract 3 from the previous term to get the next term. Some problems for the pattern can also involve the pattern of dots, where we need to find out the number and the position of the dots in the pattern. In the given example, we found out that the pattern by giving the dots that we are added to the next figure. Algebraic expression. It is a combination of constant and variables along with at least one mathematical operation. Constant. In algebra, constant is a number on its own that stands to have a fixed value. Variable. In algebra, variable is a symbol or letter for the value we do not know yet. Coefficients. Numerical coefficient. A constant multiplied to a variable. Literal coefficient, a variable. Term. In algebra, it is a constant or a variable, or a constant and variable multiplied together. Degree of polynomials. To know the degree of polynomial, look at its largest exponent. Exponents. It tells us how many times the base is multiplied to itself. As what you see in the example, we have 4 terms and the degree of this polynomial is degree of 3, since 3 is the largest value of the exponent. Monomial, polynomial with 1 term. Binomial, polynomial with 2 terms. Trinomial, polynomial with 3 terms. And lastly, polynomials, polynomials with 4 or more terms.
And that's for the pattern and algebra. I hope you learned something. And now, let us proceed to our next lesson, which is factors of polynomial, by starting the definition of it.
Factors of polynomials. Factoring polynomials is the reverse process of multiplying polynomials. When a polynomial is factored, it is written as a product of 2 or more prime factors. It is important that basic concept of special product recalled, which will definitely simplify the understanding of factoring process for some polynomials. Factoring polynomials is the process of decomposing a polynomials into a product of 2 or more polynomials. Factoring, writing a polynomial as a product of polynomials. Factors, either numbers or polynomials. When an integer is written as a product of integers, each of the integers in the product is a factor of the original number. When a polynomial is written as a product of polynomials, each of the polynomial in the product is a factor of the original polynomial. Greatest common factor. It is the largest quantity that is factor of all the integers or polynomials involved. Finding the GCF of a list of integers or terms. Number 1. Prime factors the numbers. Number 2. Identify common prime factors. Number 3. Take the product of all common prime factors, and if there is no common prime factors and the GCF is 1. First example is 12 and 8. 2 times 2 times 3 is equal to 12. 2 times 2 times 2 is equal to 8. So the GCF is 2 times 2 equal 4. Example is 7 and 20. 1 times 7 is equal to 7. 2 times 2 times 5 is equal to 20. So there are no common prime factor for this example. So the GCF is 1. Third example is 6, 8, and 46. 2 times 3 is equal to 6. 2 times 2 times 2 is equal to 8. 2 times 23 is equal to 46. So the GCF is 2. This example is 144, 256, and 300. 2 times 2 times 2 times 3 times 3 is equal to 144. 2 times 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 2 is equal to 256. 2 times 2 times 3 times 5 times 5 is equal to 300. So the GCF is 2 times 2 equal to 4. The next example is x cubed and x raised to 7. X times x times x is equal to x cubed. X times x times x times x times x times x times x is equal to x raised to 7. So the GCF is x times x times x equal x cubed. Given is 6x raised to 5 and 4x cubed. 2 times 3 times x times x times x times x times x is equal to 6x raised to 5. 2 times 2 times x times x times x is equal to 4x cubed. So the GCF is 2 times x times x times x is equal to 2x cubed. This is our next example. A times A times A times B times B is equal to x cubed B squared. A times A times B times B times B times B times B is equal to x squared B raised to 5. A times A times A times A times B 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 is equal to A raised to 4 B raised to 7.
So, the GCF is A times A times B times B is equal to A squared B squared. Note that the GCF of terms containing variables will use the smallest exponent found among the individual terms of each variable. The first step in factoring polynomial is to find the GCF of all its terms. Then we write the polynomial as a product by factoring out the GCF from all the terms. The remaining factors in each term will form a polynomial. Example is 6x cubed minus 9x squared plus 12x. 3 times x times 2 times x squared minus 3 times x times 3 times x plus 3 times x times 4 equal 3x 2x squared minus 3x plus 4. So our next example is 14x cubed y plus 7x squared y minus 7xy. 7 times x times y times 2 times x squared plus 7 times x times y times x minus 7 times x times y times 1 equal 7xy 2x squared plus x minus 1. Next example is x squared minus 16. X plus 4, x minus 4. Next example is x squared minus 64. X plus 8, x minus 8. I hope you learned something.